Going to jump into the live presentation now, and let's go ahead and get started here. I'm going to pull my STAAD Pro over here on this screen and open it up. Hopefully everybody is having an easy time viewing my screen now. So I apologize, I should have actually done an audio visual check at the beginning here, so I'm going to confirm that now so I don't get through this whole presentation and you guys can't see my screen. So under this icon here, you have a smiley face. So if everybody could just give me a smiley face if my audio is coming through and video. Okay, excellent, excellent, thank you. Now there was a question here, and we will take additional questions at the end, but I'll just address this right now. Can we download this video after finishing this live webinar? It will not be immediately available, and it will be available eventually on the Learn server, and you'll be able to stream that on demand. So this will be a video that will be on demand that you'll be able to stream and watch 24 hours a day, okay, at any point. So that hopefully I answered your question on that. Okay, so let's get into our first topic. Let's talk about instability. So I'm going to open up my file here. Okay, and we're going to look at this structure. Okay, now this may not be the exact type of structure that you work on, but we'll take a look at what's in this model, and then we'll talk about what issues are with this model, and then we'll look at how do we resolve them. Okay, so essentially you know, we have a bunch of different members that are specified in here. This is a drilled tower, so standard sections from AISC code, and then we have some specifications. So these are our properties, and then we have some specifications that have been applied. So in this model, we have some members that have been released at their ends. So when I select this specification, you can see at the start of the member, we are releasing the moments at each one of those end connections. So the moment in the X, Y, and Z have been released at these locations. And maybe I'll zoom in a little bit so you can see that. And so these specifications have been applied to the model, and then at these ends some additional releases have been applied. Then other members were specified as truss members. So if I check this box, it'll actually highlight all the members that are specified as trusses. So up here we have these members that have been specified as truss members, and then we have some tension only members that have been specified. So this is not a good way of approaching your STAAD model. You want to be very specific in how you're doing these types of specifications. So if you're using releases, generally you want to use those releases on similar members. So if you have a beam that you're releasing the ends there, you want to do that. And then if you have bracing that you're doing trussing, specifying as truss members, you want to do that for bracing. But you don't want to have necessarily beams and braces specified with the same end specification. So you want to kind of be consistent in your modeling technique is my point here. So let's go ahead and run the analysis and take a look at some of the results we're getting. Okay, and as I go through this, if you have questions, you know, you can certainly write those down, and I'll address them in our discussion at the end. Okay, so look at this. We have 31 errors and 0 warnings. So immediately it's not going to even process this model. So we're going to have to fix that. So if I look at what is going on here, it's telling me I have an issue with my member releases, my trusses, my tension, and compression only specification. So we're getting a lot of errors here. Okay, so how can we resolve that? I'm going to jump into another model, and this model has already been updated, and simply what I did was I removed some of those specifications. So we'll go back to the general tab, back to the specification tab, And notice that some of those specifications were removed. So if I highlight here, um, I don't have all of those. Now, let's try and run the analysis one more time and see what happens. So it's going to take a little bit of time to process because we do have a lot of members in here. So it's processing through. So it's looking like there's no errors. So that we have 0 errors, but we have 44 warnings. So let's take a look at that and see what those warnings are. All right, so now with these warnings, it essentially says, okay, your model ran correctly, but you have instability at all of these locations. So that means that your results are not necessarily going to be accurate because you're getting all of these instability issues. So you want to resolve these instability issues by focusing on how you've specified your end releases or your member trust specifications. So let's talk about this for a second because maybe you may not know exactly how to specify these. So if I click on this beam button here, these are all my member specifications, okay? And we have the option to release at the end of a member. We can release forces or moments, okay? So in this case, I've just been focusing on moments. So essentially, I'm trying to represent the actual connection, how the structure is going to be built in real life. So if I release MX, MY, and MZ, essentially I'm saying I have a ball joint at that location at the end of that member, meaning I can rotate it in any direction 360 degrees and it will be released. So the forces will transfer, but the moments will not transfer at that point. Now most of the time you do not want to release all 3 of these because this, especially MX, that's your torsional moment there. So if you're releasing your torsional moment, you're essentially saying that member can spin about its longitudinal axis. And in some situations that may be the case, but in most situations it's not, based on the type of connection, whether it's bolted or welded. And so in general we don't want to release MX. So this is not, generally we're not going to use the specification where we release MX, MY, and MZ. We will, however, use this other specification at the start and end where we're releasing MY and MZ only. Okay, and then the other one that we want to use more is going to be member truss, which is saying, okay, I have a bracing member, and those members are only going to take axial load. They're only going to resist axial load, so there will not be any bending in those members, so we won't see bending forces. Okay. So those are 2 specifications I recommend using on a regular basis, and in certain situations, if it does apply, to use this one only in certain situations. So ultimately we want to resolve all of these instability issues. So one way to do that is simply removing these specifications and just applying a member truss. So I like to start simple and then build from simple. So this one way to start out is just say, okay, I'm going to start with all my members that I know are truss members. Let me specify those first, and then I'll look at the releases, and I'll do it step by step. So I won't run into any. If I do run into instability, I know how I have actually created it. Okay, so it's better to start simple and then build from there. So we're going to go and look at this 3rd model, and in this 3rd model here, we go to the General tab, and then we go back to our specifications. So all I have here is for my bracing members. You can see those are all specified as trusses. Okay, so I have those done, and my vertical members, my columns, I'm going to leave them as basically one continuous member. So they're going to take axial load, they're going to take bending, and all of that. Okay, so when I finally run this analysis, you'll see that we should not have any instability in this situation. Okay, this is going to just take another few moments here to process. Okay, so we have 0 errors. We do have 10 warnings. And I do always recommend going through your warnings and understanding what they are. So looks like we do have a little instability at one location, but we don't have all of those cases. So I would want to go back and just figure out why that one location I'm having some instability here. But overall, it's not looking too bad. So it should be an easy fix here. When I start to investigate, I can focus in right at this one location and see why that is. Okay, so like I said, start simple and then build from there. If you want to add on additional specifications, you can do that, but start simple and then build out. Okay, now let's take